Hello students. Functions are a mechanism for reusing parts of code multiple times. They allow you to execute the same code from different parts of the program without the need to copy it. Additionally, by hiding complex code fragments inside functions, you can focus more on designing the program. You'll be establishing interactions between functions rather than getting bogged down in the details of these code fragments. Organizing code into small, easily manageable parts allows you to see the big picture and think about the structure of the program at a higher level. Functions are very convenient when you need to repeatedly perform calculations or other actions in a program. We have already used built-in functions such as random number generation, rounding, modulus, and so on. In this lesson, we will learn how to create our own functions. Creating a function is extremely simple. This is handled by the function block. Everything we connect to it will be the body of the function, which will be executed every time we call this function. You can call a function using the call function block. Let's start with simple examples. Let's create a function that prints the phrase "Hello World." We take the function block. In the function text field, you need to enter the name of the function. It can be almost anything. But, as with variables, you should try to choose a name that reflects the essence of the function. Looking at the name, you should immediately understand what this function is responsible for. Let's name this function output. Now we take the print block and connect it to the function block. We enter the traditional string into it, "Hello World." That's all. The function is ready. Now we need to call the function using the call function block. Specify the name of the function to be called output. And connect the function call, for example, to the space key. You also need to specify the logical branch in which this function is located. In this case, the function is in the same logical branch, so we connect the self-create block to the channel. We run the console, press space. We see the message. Let's make the example more complicated. Right now, our function outputs the same string every time it's called, but we would like the behavior of the function to be controllable, so that the function can change behavior depending on values. For this, we need arguments. Let's change the body of the function. Now we will output a greeting to a person by name. Let's use string concatenation. We need 3 inputs. In the first one, we write "hello" space, and in the third field, we insert an exclamation mark. And we should connect the argument of the function to the second input. Press the Add Argument button and connect the argument to the second channel. Now let's move on to calling the function. We also add an argument and connect a string block to the input that appears. When calling a function that takes an argument, you need to enter the value you want to use as this argument in the string block. Each time the function is called, the argument we passed is substituted into the string printed by the function. For example, to greet Anna, you can enter the name Anna. Then when calling the function, we will see the greeting in the console. "Hello Anna." Or, if we enter another name, for example, Peter, we will get the greeting, "Hello Peter." The argument passed to the function can indicate not only string values with a name. For example, the argument can be a number that indicates how many times something needs to be done. Let's change the body of the function. Now we need 2 arguments. We'll connect the first argument to the to channel on the loop block. This argument will mean the number of repetitions. And the second argument will be a string that we will output to the console. Let's combine all this into one common string. Connect the index of repetition to the first field. In the second field, we'll write the delimiter. For example, space, colon, space. And connect the second argument of the function to the third field. Now let's proceed to the function call. Connect an integer block to the first argument and enter any number, for instance, 10. Connect a string block to the second argument and print a smiley. Now pressing the space key will output 10 lines with smileys in the console. Each line will be numbered from 0 to 9. Now, if we want to change the smiley or the number of smileys, we don't need to change the script. We just need to call the existing function with the necessary parameters. Change the smiley, change the quantity, and we'll have the desired smileys in the console. So far, all our functions have printed text to the console using the print block. This is a simple and convenient way to display data. However, we won't be able to take this value from the console and use it in the code later on. If we want to get some value from the function and use it in other parts of the program, we need to organize a return. Functions can return values. By calling a function that returns a value, we can then use this value in our program by saving it to a variable, passing it to another function, or combining it with other data. Let's modify the function body again. Both function arguments will be integers, and we will add them together. Then we will return the obtained sum using the function output block. In the name field, specify the name of our function and connect the obtained sum to the value channel. Now let's move on to the function call. We no longer need the string. Connect integer blocks to both arguments. Enter any two numbers into them, for example, 10 and 25, and print the returned value from the result output to the console. In the console, we'll get 35. So, the return value is the value that the function outputs so that it can be used anywhere in the program. Right now, we are just printing it to the console. But we can save it to a variable. Instead of the print block, let's connect a setter. Let's name the variable sum. And to make sure everything works, let's output the value of the new variable to the console. Also, a function call can be specified as an argument of another function, where the argument will receive the value returned by the first function. Let's duplicate the function call twice. Connect them sequentially to the space key. In the first call, specify the values 2 and 3. In the second call, 5 and 10. And now connect the returned values to the third call. So, the first function will return the value 5. The second function will return 15. And the third function will take these two values as arguments, add them up, and return the value 20. To sum up, functions allow you to reuse code fragments where needed. Functions can behave differently depending on the passed arguments and can return a value to the part of the code from which they were called. Additionally, functions allow you to name code fragments with understandable names so that by looking at the name, we can immediately understand what the function does. And now, here's another way to do the same thing, but a little differently. In the right panel, switch to the Armory tab. Press this button here. Something like Add Node Group Call. A block like this will appear on the screen. Press New, and now we see two blocks. In fact, here's what happened. We are currently inside a group. To exit back to the logical branch, you can press the Go to Parent Node Tree button. You can also do it by pressing Ctrl Tab. We are back in the logical branch, and we have a block where we can weave a web of other blocks inside it. In other words, write the body of the function. This block has a name, and we can change it. Let's start with this. Let's name the block checksum. The block also has one input and one output. And this can also be changed. To enter the group, select the block and press Tab. Or press the Edit Tree button. Anything we place between these two blocks will be the body of the function. Let's calculate the sum of the two arguments. Add another channel to the left block. And connect both channels to the addition block. Connect the result to the right block. That's it. The simple function is ready. Let's try calling it and outputting the result to the console. As always, connect the print block to the space key and print the sum to the console. Enter any values into the input fields, let it be 5 and 15. Run the console, and we get the result by pressing the space key. In the console, we see the number 20. Great, everything works. Let's make the example a bit more complicated. In the function body, let's add a gate block and compare the obtained sum with the number 10. If the sum is greater than 10, we'll output the result to the console. And if the sum is less than 10, we'll output a string message about it. To activate the gate block, we need a control signal. So, add another channel to the input block and connect it to the gate block. To avoid confusion in this mess, we can give understandable names to the channels and switch their positions. Select the input block. In the right panel, switch to the Node tab. Select the In channel and move it up. Rename it to Start. Rename the numerical channels to num1 and num2. From now on, we can connect our function to the space key. Now we need a variable. Connect setters to both channels of the gate block. Let's name the variable result. If the check returns true, then we'll write the obtained sum to the variable. And if the check fails, then we'll write the message not enough to the variable. Retrieve the merge block, connect both options to it. Select the output block. Add another channel in the right panel. Move it up and name it Done. Connect the merge block to this channel. Rename the second channel to Result and connect the result getter to it. Exit outside. Connect the print block to the Done channel and output the result to the console. Call the function with the values 8 and 6. The sum of these two numbers is greater than 10, so we'll see the number 14 in the console. Let's change the argument values to 5 and 2. Now the sum is less than 10, so the console will output the string not enough. I like this method of organizing code better. But it has a downside. Sometimes, when making changes, these changes are not taken into account during compilation. And when you run the console, you don't see the result of these changes. And you think that your code doesn't work because you made a mistake, and you dive into the code and try to catch this error. But in reality, there is no mistake. You just need to save the file, and after saving, run the game again. And sometimes, even that is not enough. And you need to close the file and then reopen it. After restarting the project, All changes in the code will be guaranteed to be compiled when the game is launched. Well, that's all for today. In the next lesson, we'll try to apply the knowledge gained to some challenging example. Don't be bored. Bye for now.